Question 5. Calculate the volume of 0.2286 molar iron 2 sulfate, which is this one here, required to reduce a 20 ml solution of 0.05643 potassium permanganate. That's this one here, according to the below equation. And it's a big long-winded equation, okay, but it's already balanced, so that's nice and handy. So what we're going to do, we're going to split the page into two. We're going to do our potassium permanganate equations on this side, and then our iron sulfate calculations on this side. Normally I do them directly underneath what you're trying to calculate, but it's just going to get too squishy with two ones over here. So let's look at what's in our question. Calculate the volume of iron sulfate. V equals question mark. Of 0.2286 molar iron 2 sulfate. Now some people see that capital M and confuse it with mole. It's actually a concentration, 0.2286 molar. Okay. Required to reduce a 20 ml solution of potassium permanganate. So we've got a volume of potassium permanganate, 20.00 mils. I'm going to convert that straight away into litres so we don't make a mistake later. So that's 0.020 litres of 0.05643 molar potassium permanganate. So we've got a concentration, 0.05643 molar, according to the below equation. Okay, this is our starting point. This is our finishing point. Okay, this is where we're starting. This is what we want to find out. So we've got a concentration of volume. So we're going to do number of moles equals C times V. C is 0.05643 times by our volume in litres. Remember, that's not mils, it's litres. So if we throw that in the calculator, we get 0.001129 mole. Okay. Again, this is a want over got, just like question 4, we use want over got, or want divided by got. The number of moles of iron sulfate equals the number of moles of potassium permanganate times by want divided by got. Want in this case is our 10 and got is our 2. If you're a bit unsure about this, go back to have a look at the video for question 4 and there's a bit more of an explanation there. So we've got N equals 0.001129 times by 10 divided by 2. Put that in the calculator and we get 0.00563 mole. Okay, we want to find the volume. We've got concentration and number of moles, so volume equals N divided by C. N is 0.00563 mole divided by our concentration, 0.2286 molar. And if you throw that in the calculator, we get 0.02469 litres. Now, if we look at our question, we've got 4 significant figures here. We don't count the zeros before, but we do count the zeros after. So we've got four significant figures, 4 significant figures. We've got 4 significant figures here. Again, it doesn't say the volume in mils or the volume in litres, but I would probably convert that one to mils just to make it look a little bit prettier. So we times that by 1,000, we get 24.69 mils, and that's our answer, so we'll underline that too.